Hello friends, in today's session we are going to start with a new chapter, that is chapter 12, input output in Java. We will start with the streams first. Java programs perform input output through streams, that is input stream and output stream. A stream is an abstraction that either produces or consumes the information. Okay, so if you are producing information, that is you are writing, and consuming means you are reading the data. Stream is linked to a physical device by Java input output system, and all streams behave in the same manner irrespective of what devices you are using, even if the actual physical devices to which they are linked differ. Okay, so it may be your CD drive, your pen drive, or your writing, your console output with your monitor, like that. Okay, the same input output classes and methods can be applied to any type of device that you are using. Input stream can abstract many different types of input: disk file, keyboard, network, socket. This kind of input is like input stream. And output stream may refer to the console, the disk file or network connection, and all those external devices that we are using. Those can be handled by same input output classes, that is same input output streams. Streams are a clean way to deal with input output without having every part of your code understand the difference between keyboard and network. For example, if anything that is inputting for your program or inputting anything, that will be handled or treated as your input device, and anything that is used for output like a console, it will be handled or treated as a output device. Java implements streams within class hierarchies defined in the Java IO package. Byte stream and character stream. Java defines two types of streams, byte and character. Byte streams provide a convenient means for handling input and output of bytes, and for example, when reading or writing binary data. Such type of data is handled by byte stream. Character streams provide convenient means for handling input and output of characters. They use Unicode and therefore can be internationalized. So for character streams, this is the international or worldwide use of character stream. For our program, for our course that we are using, that is Java course I am creating, in that course we have used the byte stream only. So character stream is for worldwide use, and they use the Unicode character set to handle all types of languages, all types of character set that is used worldwide. Some cases, character streams are more efficient than byte streams. They are overridden by derived stream classes. The character-based streams simply provide convenient and efficient means for handling characters. Overview of both byte-oriented streams and character-oriented streams is presented now in the following upcoming PPTs. Now we will start with the byte stream. Byte stream are defined by using two class hierarchy. At the top are two abstract classes, input and output streams. Each of these abstract classes has several concrete subclasses that handle differences between various devices, disk file, network connection, and even memory buffers. Okay, so there are two stream classes, input stream and output stream. They handle the differences between the input and output devices provided. To use the stream classes, you must import java.input output. Okay, that is the important thing you have to import. Character stream classes are defined by using two class hierarchies, reader and writer. Top of two abstract classes, reader and writer. These abstract classes handle Unicode character streams. Java has several concrete subclasses of each of these. The abstract classes reader and writers define several key methods that other stream classes implement. Okay, so base class of character streams is reader and writer. They handle Unicode character streams, and base classes of byte stream are input and output stream. Okay, now we will see the byte stream classes. Buffered, these are the classes, and what does it contain or what does it mean? It is written over here. Buffered input stream is for buffered input stream. Buffered output is for buffered output stream. Byte array input stream that reads from a byte array output stream that writes to a byte array, data input stream and input stream that contains methods for reading the Java standard data types. Okay, the data input stream is nothing but input stream that inputs the data that contains method for reading the Java standard data types, that is integer, float and double, like that. Data output stream is output stream that contains method for writing the Java standard data types. File input stream that reads from file. File output stream is output stream that writes to a file. Filter input stream implements input stream, and filter output stream is this class implements output stream. Now, input stream is the abstract class that describes the stream input. So, input stream is the abstract class, and this class is implemented by filter input stream. Same way, output stream is the abstract class, it is implemented by filter output stream. Input stream, it describes the stream input, object input stream, in the input stream for object, output stream for object is object output stream. Output stream is the abstract class, it is not having the definition of the methods, and it is implemented by filter output stream here. Piped input stream is for input pipe, piped output stream for output pipe, print stream output stream that contains print and println. Okay, all these methods are very important. You can write it down, or you can take a screenshot, or you can take a photo. Okay, pushback input stream that supports 1 byte ungate, which returns a byte to the input stream. Random access file supports random access file input output. Sequence input stream, that is a combination of 2 or more input streams that will be read sequentially, one after another. Then character stream input output classes. Buffer reader, buffered input character stream. Buffer writer, buffered output character stream. Then character array reader input stream that reads from a character array. Character array writer is output stream that writes to a character array. File reader input stream that reads from a file. File writer is the output stream that writes to a file. Filter reader is a filter reader, and filter writer is a filter writer. Then input stream reader, input stream that translates bytes to character. Line number reader, input stream that counts lines. Output stream writer, output stream that translates characters to bytes. Pipe reader is a input pipe. Pipe writer is output pipe. Print writer is output stream that contains print and println. Okay, pushback reader, input stream that allows characters to be written to the input stream. So whatever will be written, whatever will be read from that, characters will be written from the pushback reader. Reader is abstract class that describes character stream input. Okay, so reader class is also not implemented. It is an abstract class. It is an abstract class that it describes the character stream input. String reader input stream that reads from a string. String writer output stream that writes to a string. Writer is abstract class that describes character stream output. Now we will see predefined streams. Java programs automatically import java.lang package. Okay, so all this stuff is written inside the java.lang, and it automatically imports that package. This package defines class called system, which encapsulates several aspects of the runtime environment. This package has a class called system, and it has several aspects of the runtime environment. System.in will give you the system input, and system.output, that is system.out.println, is the output to the console. Using some of its method, you can obtain the current time and settings of various properties associated with the system. System also contains the predefined streams in, out, and error. Okay, so using system variable or data, you can have the time and settings of various properties associated with the system. So this class system is inside java.lang package, and which is automatically imported. And it has 3 predefined stream variables: system.input, system.output, and system.error. These fields are declared as public, static, and final. Why they are public? Because system.input and system.output we use as a any program that we are importing, in which we are importing java.lang package. For that purpose, it is public. Why it is static? It should be used without creating the object of system class. So we can directly use it as system.variable name, that is system.in and system.out. Why it is final? Its value you cannot change. If you will change its value, the output will be different every time. So that it is called as, it is declared as final. This means that they can be used by any other part of your program and without reference to a specific system object. System.out refers to the standard output stream. This is the console. System.in refers to standard input, which is the keyboard by default. So standard output stream by default is a console. Standard input stream is a by default keyboard. System.error refers to the standard error stream, which is also the console. So whatever errors you will see, where you will see them on the console. So system.error is by default is a console. However, these streams may be redirected to any compatible input output device as you wish. Okay. So by default they are console, and keyboard, but you can redirect to any other device. System.in is an object of type input stream. System.out and error are objects of type print stream. And these all are byte streams because in our course we are using the byte stream also only. Even though they typically are used to read and write characters from and to the console. They are by default byte streams. You can wrap this within the character-based streams if desired. The preceding chapters we have been using system.out in their example like system.out.println to print the output. And you can also use the system.error in the same way as you are using system.out. As explained, use of system.in is a little more complicated. Now, reading console input. In Java 1.0, the only way to perform console input was to use a byte stream. And our older code that uses this approach persists. Okay. So byte stream was there, character stream was found out later. So before Java, in Java 1.0, there was only one way to use input output was the byte stream. Using byte stream to read console input is still technically possible, but doing so is not recommended because Java applications are worldwide used. And for worldwide use, they should use character-based streams. The preferred method of reading console input used a character-oriented stream, which makes your program easier to internationalize and maintain. Console input is accomplished by reading from system input. To obtain a character-based stream that is attached to a console, wrap system.in in a buffer reader object. Okay. So if you want to access a character-based stream that is attached to the console, you have to wrap system.in in a buffer reader object. And buffer reader supports the buffered input stream. Okay, so how you will create the object of buffered input stream? Buffered input stream is equal to buffer reader in bracket. You will specify the system.in to wrap it and you will obtain the character-based stream. The most commonly used constructor is buffer reader, reader, input reader. But here input reader is a stream that is linked to the instance of the buffer reader that is being created. Okay. So input reader is nothing but the stream that is linked to the instance of the buffer reader. Okay. So reader class we have already seen here. Abstract class that describes the character stream input. Okay, this is only available in the character-based stream. So abstract class, reader is abstract class that describes the character stream input. Since it is abstract class, this cannot be instantiated. So what you will do here, you will this object is of abstract class. So you will you will link it to the instance of buffer reader object. And how to create buffer reader object? By using the system.in variable. So we will see in the next coming PPTs. Reader is an abstract class, first of all. One of its concrete subclasses is input stream reader, which converts bytes to characters. So very famously or very generally used classes is input stream reader. So to obtain the input stream reader object that is linked to system.in, how you will do it? Input stream reader in bracket system.in. You will specify in the bracket system.input. Because system.input refers to object of input stream, it can be used for input stream. Putting it all together, following line will display all the things together. Buffer reader BR. So you will create the object of buffer reader is equal to new buffer reader in bracket new input stream reader. Why input stream reader? Why not reader? Because reader is an abstract class. This is a constructor. But reader is an abstract class. This cannot be instantiated. So we will have to use the object of class input stream reader. And this is the constructor for input stream reader. New input stream reader will create the object of input stream reader. And in bracket we will specify the input stream, that is system.in. Okay. So buffer reader BR is equal to new buffer reader, new input stream reader system.in. You can by heart this line as well, or you can learn it too. Okay. After this statement executed, BR is a character based stream that is linked to the console through system.input. Okay. So whatever input will be given to the console through system.in will be converted to character based stream using this line. Okay. You have to remember this. You can write it down. You can take a photo or you can take a screenshot. But this line is very important. If you are not understanding this, you can go back again and try to understand all the stuff all together. Okay. Then reading characters. To read a character from a buffer reader, use read method. The version of read that we will be using is int read throws exception. Each time the read is called, it reads the character from the input stream and returns it as an integer value. Okay. So what is the version of read? It will throw the input output exception. Okay. Input output exception is thrown when there is error while reading the input or output device. And each time it is called, it reads a character from the input and returns an integer value. So every character will be read one by one, and it will be written. And if all the characters have been read and only finished with all the stuff, it will return the 1 when the end of stream is encountered. As you can see, it can throw input output exception. When reading from the console, you will use this approach, but you can handle these errors by yourself if you choose. Okay. So read characters one by one from the console. How you will read it? Buffer reader BR is equal to new buffer reader, new input stream reader system.in. So whatever user will be entering through the keyboard. Why keyboard? Because the default input device is keyboard by default. Default output device is console and default error device is also console, as we have seen in the PowerPoint presentation before. Now, whenever you will start entering, unless and until you are stopping with Q, this line will be used to read characters one by one. Read characters to buffer.read, it will return and character is casted. C will use to store this character and print this character while C is not equal to Q. When user will enter Q, they will stop entering. They will stop reading. Enter characters Q to quit. 1, 2, 3, A, B, C, Q. Okay. When all characters are entered and Q is entered, it will stop. And then display is output like 1, 2, 3, A, B, C and Q. This output may look like a little different from what you expected because system is line buffered by default. What do you mean by line buffered? When all the stuff or all the characters has been entered, then only actual process or actual performance of program, execution of program starts. It is not reading it one by one unless and until you are pressing Q. It will read all the stuff in line and then it will start reading it. No input is actually passed to the program until you start pressing enter. As you can guess, this does not make read particularly valuable for interactive console input. For interactive means when input is given, output is given at the same time. Okay, so it is much interactive, much user friendly, cooperative, but in this case, read is not particularly valuable for interactive console input. Now reading strings. To read a string from the keyboard, use the version of readline that is member of the buffer reader class. So what is the general format or syntax string readline? So readline will return what string and it will throw IO exception as before. As you can see, it returns string and following programs will tell you buffer reader and the readline method. The program reads and displays the lines of text until you enter the word stop. Now, this is also throws IO exception. System.in, create a buffer reader using system.in. Buffer reader BR is equal to new buffer reader, new input stream reader. Sorry, I have not given comment here. This is a one line, this is a commented line. Do not enter it over here. Or you can enter from here. This is the line of code. Buffer reader BR is equal to new buffer reader, new input string reader, system.in. A string is created to store the string. Then I enter lines of text. Enter stop to quit. Okay. So buffer.readline will give me the string. I will display that string unless and until I enter stop. Okay. Now we will see the tiny text editor. It creates an array of string objects and then reads in lines of text, storing each line in the array. And it will read up to 100 lines or until you enter stop. So there are two possibilities to stop the program. It will read at least 100 lines, maximum 100 lines, or until you enter stop. It uses buffer reader to read from the console. So tiny editor is here. Buffer reader BR is equal to new buffer reader, new input stream reader, system.input. String str is equal to new string 100. Enter lines of text, enter stop to quit. Now, buffer.readline. At every string index, that is string of 0, string of 1 up to string of 100, it will be storing the string. And if string of I equals stop, break. Otherwise, it will continue. Here is your file. If string of I equals stop, break. Otherwise, print the string. Enter lines of text. Enter stop to quit. This is line 1. This is line 2. Java makes working with strings easy. Just create string objects. And then this is line 1 entered. This is line 1. This is line 2 is entered. Then enter. Then Java makes working with string easy. Just create string object and then stop. When I am entering stop, so entering or inputting is stopped over here. So it will display me the whatever input I have made. This is line 1. After that, this is line 2. After that, Java makes working with strings easy. Just create string objects. Now, writing console output. Sorry. Console output is most easily accomplished with print and println that we have already used. That is system.out.print and system.out.println. Only difference is print is not having the new line and println is having new line after the message is displayed. These methods are defined by the print stream class, which is the type of object referenced by the type system.out. Even though system.out is a byte stream, using it for simple program output is still acceptable. That is, for nowadays program, we can still use the system.out.println. Okay, because it is a simple program, it is not for worldwide use. Because print stream is an output stream derived from the output stream class, it also implements the low level method write. So what is the base class of print stream? Output stream, and it also implements the method write. Write can be used to write the console. The simplest form of write is void write in bracket integer byte value. This method writes to the stream the byte specified by the byte value. Although byte value is declared as an integer, only the low order 8 bits are written. Okay. Byte value we are declaring it as integer. Only not 32 bits, only low order 8 bits are written actually. This is a short example we will be seeing. Then Write demo public static void main b is equal to a, and we are writing b. Okay. You will not often use write to perform console output, although doing so might be useful in some situations because print and println are substantially easier to use. Okay. System.out.print and println is already there. You can use them or you can use these two. It is dependent upon you. But print and println is easier than this write. Then print writer class. The system.out to write the console is still acceptable. Its use is recommended mostly for debugging purposes or for simple programs such as those found in this course. For real-world programs that are worldwide use, the recommended method for writing to console when using Java is through a print writer stream. That is for worldwide use like applets. Print writer is one of the character-based classes, and whatever that we are using till date is byte-oriented classes. Using a character-based class for console and output makes it easier for internationalize your program. Print writer defines several constructors. One of it, print writer, output stream, boolean flush on new line. Output stream an object of type output stream, and flush on new line controls whether Java flushes the output stream every time a println method is called. Okay, so first is object of class output stream, and second is flush on new line. So if flush on line new line is true, flushing on new line automatically takes place. Otherwise, it will not be automatic. You have to enter. You have to press enter to go into the new line. Then print writer supports the print and println methods for all types, including object. Thus, you can use these methods in the same way as they have used by the system.out. Okay. So print writer supports the all methods using print and println, including object. And if an argument is not simple type, print writer methods call the object toString method and then print the result. Okay, so it will call the by default inbuilt toString method, and its argument is like, for example, int value plus I. So if I is integer, what it will do? It will concatenate the integer with the string. First of all, it will convert that integer to string, then it will concatenate that string with our string, and then it will display the output. To write the console by using print writer, specify system.out for the output stream and flush the stream after each new line, so it will be true. Okay, so how you will write it? New print writer pw is equal to new print writer system.out comma true. So every time output is done, it will flush on new line. So we will see the example for this print writer demo. Print writer is equal to new print writer system.out true. This is the string. Integer I is equal to 7. Print pw.println I. So here -7 is not a string. So it will call toString method. Then it will convert this -7 to string -7, and then it will display the output. Double D 4.5 E -7 is also not a string. So what it will do? It will call its toString method, convert this 4.5 E -7 to string 4.5 E -7, and then it will display the output. This is the string -7 4.5 E -7. There is nothing wrong with the using system.out to write simple text output to the console when you are learning Java or debugging your programs. That is for simple programs, or you are learning the Java. You are beginner with Java, you are learning and you are trying to debug your programs. In that cases, you can use the system.out.println. But using a print writer will make your real world application easier to internationalize. So if you start writing with the print writer classes or methods, what it will be easier for you to internationalize your program. When your all program is finished or your all application is done, so what you will do? You will just internationalize your code. But if you are if you are doing with the system.out.println such method, what you have to do after writing all applications, after debugging all, you will start changing that println with the print writer methods. Because no advantage is gained by using print writer in the sample program shown in our Java course, we will continue to use system.out.write to the console. Okay. So this way we have finished with the part 1 of input output in Java. In the next session, I will try to cover the remaining topics of input output in Java, and then we will start with the practical part. So meet you in the next session. Thank you so much.